Alright, so this formula that we're looking at shows the relationship between acceleration, velocity, and time. And we have already used it to calculate acceleration by doing change in velocity over change in time. But we can also use it to calculate the change in velocity or calculate the change in time. Pause the video here to see if you can work out these rearranged formulae. So you can either rearrange it through traditional mathematical methods, but if that's not your forte, remember you can use the formula triangle. So we draw the outline of our triangle with our three sections. Remembering that the horizontal line represents division, while the vertical line represents multiplication. To fill out the sections, we first look at what's after the equal sign. In this case, change in V divided by change in T. We need to maintain this division, so the change in V goes at the top, above that horizontal division line, and the change in T goes at the bottom, below the horizontal division line. Then the thing before the equal sign, in this case the A, goes in our final box. Then to use our formula triangle, we cover up what we're trying to work out. So if we're trying to work out change in velocity, we're left with A multiplied by change in T. So A times change in time. If we were trying to work out change in time, we would cover that up and we're left with change in velocity divided by acceleration. So change in V over A. Now let's put this into practice. So here's a fairly straightforward question. Becky was travelling at 2 meters per second before accelerating to a speed of 5 meters per second at a rate of 0.5 meters per second. Calculate how long it took her to accelerate. So in this case, we need to work out time, so we need to rearrange our formula. So our basic formula is A equals change in V over change in T, and you will be given that in the exam. We can use our formula triangle to rearrange this. We want to work out how long it took, so time, we cover that up. So we're left with time equals change in velocity over acceleration. So we've got our formula. Then we need to work it out. So change in velocity, we do need to calculate that. Remember, it is the final, in this case 5, minus the initial, in this case 2, because that's what she started at. So 5 minus 2, divided by the acceleration, which was 0.5. So we have 5 minus 2 is 3, divided by 0.5. And if we calculate that, we end up with 6. And since we're working out time, the unit is seconds. So it took 6 seconds for Becky to accelerate from 2 meters per second to 5 meters per second at a rate of 0.5 meters per second. Got that? Alright, now let's try a slightly harder one. Pause the video here and have a go yourself, and then we'll go through it together. Alright, so for this question, Blake was travelling at 1.2 meters per second. He then accelerated at a rate of 2.5 meters per second for 0.8 seconds. and we need to calculate his final velocity. So we've been given his initial velocity. We're going to calculate his change in velocity and then use that to work out his final velocity. So first up, we need to figure out our formula. We're looking at the relationship between acceleration, velocity, and time. So that's our base formula. We use our formula triangle to rearrange it. We're trying to calculate stuff to do with velocity, so we'll cover that up. And we now know that change in velocity equals acceleration times change in time. So we've got our formula. Alright, so Blake's acceleration is 2.5 meters per second, and we multiply that by 0.8, the time. We can enter that into our calculator to give us 2. So Blake's change in velocity is 2 meters per second. Now remember though, we wanted to calculate the final velocity. So if he started at 1.2 meters per second and he changed that velocity by 2, we add them together. So Blake's final velocity is 3.2 meters per second. So this one has that additional step where you're comparing that change in velocity to work out his final from his initial.